x minus 4y equals to 8. So if I keep x on one side, make this guy cross the border, it becomes 8 plus 4y. So I got the value of 8x in terms of y. Now look at this. I have value of x in terms of y, meaning here this part I can put the value of x, everything becomes y. So if I take this value of x and substitute here, it becomes 4 into x, which is 8 plus 4y plus 3y equal to 18. Now you have everything to play around with. It becomes 4 into 32 plus 16y plus 3y equals to 18, and then you have 19y equals, so let's say 16 plus 3, 19y on one side, and make this guy go that side, equals 18 minus 32 is minus 14, and then you can solve for it. But both the things that we did, what is the ultimate objective? I was telling you guys, substitution or elimination, whatever you call it, ultimately you are trying to get to a place where you have one equation with one variable. Yeah, this is our ultimate objective. Now whether we forget about different techniques or remember them, doesn't matter. Yes, as long as you are clear with your objective, your desired state. Your desired state is to come to a point where you have one equation with one variable, because that's the only way you can get the value for it. You need some water or something? Sure? Okay. So, I'm pretty sure, 99% sure that you all knew about this. Why I did that was just to add that one line of wrapper on the top of what you guys already know. Saying that whatever you do, be it elimination, be it substitution, you want to come to a point where you have one equation with one variable. If you look at the equation like this, it becomes very evident that okay, I can easily find out the value of x in one go. I don't have to do any magic. Or if you are very good at multiplication, and if you can envision this as with the elimination technique, it's up to you. I mean, elimination works faster, no doubt about it, but these are the options that we have. Only thing that you have to keep in mind is you are wanting to get here, because if your goal is fixed, if you know you are studying for getting a near perfect score in SAT, then you are working towards it. If your goal remains ambiguous, then if you get distracted, you will not know where to catch up. Yeah? Here with me. Savya, here. I've not heard you guys so far. Are you with me? Okay.
Yes, sir.
Okay.
Yes, sir.
Alright. So now, time to practice a little bit, and then we'll do further double click on what we have done so far. I want you guys to spend only 5 minutes for solving these two. I don't know. I had some fascination with number 7 before. Now it has switched to 4. I'm using 4 very often. 3x plus 6y equal to 18. 2x plus 5y equals to 7. I want everybody to solve this quickly in next 5 minutes. Just, I want you guys to get your hands dirty a little bit. And tell me the value of x and y before I move on. Yeah, Dave.
No, I got the answers.
Yep, tell me.
Oh, sure.
Yeah, sure.
So for my y, I got -5, and x I got 16.
Okay. Yes, Chris.
Oh, yeah, even I got the same thing.
Same thing. Ritika,
Same value, sir.
same value.
I also got the same thing.
Wonderful. Okay, so you guys are not diverse. That's what it means. Okay. Anybody else? I mean, don't put effort for being diverse. Okay. I mean, as long as it's the right solution, it has to be the right. I'm not in the lookout for diversity any which way. All right. So let me quickly solve this, because I mean, I'll just use elimination technique. As I said, I feel elimination is faster, so I'll multiply this with 3, multiply this with 2, and then that transform this to 6x plus 12y equals to 36, and this one becomes 6x plus 15y equals 21, and then I'll do a minus, round off, minus 3y equals 15, minus 3y becomes 15, y becomes minus 5, and if I use y here, it becomes minus 5, so minus 30, so 3x plus 30 equals 3x minus 30 equals 18, so 3x equals 48, x equals 16. This is what you guys got, right?
Yes, sir.
Okay, so then your teacher also has thankfully not forgotten how to do calculation. That's good. Now, I was saying that when we talk about inconsistent system of equations, meaning when they don't have a solution, and the only or the best scenario is if I'm talking about linear equations, I'm talking about two parallel lines. Yeah. Now, if I give you guys an equation which says y equals to 3x plus 8, okay. Now give me other example of a linear equation which will make it an inconsistent system of equation. Yes.
Y equals 3x plus 1.
Okay.
Y equals
Okay.
3x plus 1.
Okay. Yeah, Ritika, tell me.
3x plus 10.
Okay.
The slope has to be same, but the values can be different.
Right. Yeah. Is everybody getting what Ritika tried explaining here?
Yes, sir.
Okay. Neil, Sarah, Sunarka.
Yes, sir.
And I purposefully gave you guys a simpler example. Y equals to mx plus c. This is the standard form of a linear equation, right? Where y is obviously a y coordinate, m is the slope. Meaning slope, when we say slope, we are talking about the inclination. If the slope is more, this is going this way. Slope is less, it's going this way. Now what this way and that way means, in the examination hall you cannot draw your hand moving up and down, right? So see, look at, if I'm saying this is less slope, this is even less slope, this is more slope, what does it mean? High or low slope means how fast the value of y is changing for every unit change of x. Look at this. Here, if I'm moving x by 1, y is moving by 1. Look at this. If I'm moving x by 1, y is probably changing by 4. Yeah? So, the value of m, or the slope of the equation, that tells you how fast your y is changing for every change of x. So when we talk about the parallel lines, essentially what we are saying, my slope is the same. This has some slope. Here also the line is parallel, meaning the rate at which x is changing, the rate at which y is changing for every change of x is going to remain the same. So your m will remain the same. That's why each one of you who gave me the answer made sure that you are not changing this part. What you changed or played around with was this. Why? This is nothing but your intercept on the y-axis. Meaning, when the value of x is 0, where this line is touching. So you are moving this line along the y-axis just by changing this one and making sure that the slope doesn't get disrupted. If anybody would have told me that okay, an example of a parallel line or a system of inconsistent equations will be, for this one will be y equals to 4x plus 12, that would have gotten me concerned. Yeah. Is everybody able to relate? Arya, are you with me?
Yes, sir.
So far whatever we have discussed, are you guys able to relate? Are you able to follow me and say that yes, this makes sense?
Yes, sir.
Yes, sir.
Because
Yes, sir.
okay,
Yes.
cool. Can you guys say it loud and clear that I'm the best teacher? No, I'm just kidding. No, I'm just kidding. Trust me, I'm still a student. I'm learning. Whenever I try teaching you guys, I make sure that I revise it and first try becoming a good student before I dare to become a teacher. Okay. All right. So within system of equations, we have dealt with. So far, we were dealing with linear equations. Now, system of equation doesn't limit itself to linear equations alone. It can be system of equations, as the name says. I can have equations like this: 4x plus 3y plus 2z equal to 16, 2x plus 17y minus z equals to, let's say, 22. And if I ask you guys to solve these two, who will just get going? Who will be able to solve it with this? Yep, right. You can solve it? Are you sure?
The x guy, it's no squares and
Yep.
just create it on the slope.
Okay. Yeah, Vaibhav.
Sir, I think you can't solve this because you need 3 equations.
Yep. You have 3 variables, you need 3 equations.
I thought it was a 2.
No, 2z. See. So that's why my handwriting is little doubtful at times, but yeah. I'm not as close to being a doctor, but still, my handwriting could be little confusing. So 4x plus 3y plus 2z or whatever. Essentially, I'm trying to depict here that there are 3 variables. If I have 3 variables, the first thing is I need 3 equations. Okay, that is first thing. Now, but this is also a system equation. Nobody can deny that this is not a system equation. They are system equations. They are equations in the system. Now, and then it could be, let's say, x square plus 2y minus z, or just this. Let's do this. If I have linear, so first one, these two are linear equations. This is a quadratic equation, and that is technically possible. With system of equations, you will not have a boundary of saying, okay, I'm going to only deal with linear equations. You are going to deal with quadratic equations also. Now, let's not complicate this and look at a situation where we are dealing with So what are you seeing here? You have one equation as a linear equation, another equation as a quadratic equation. When you use coordinate plane for solving it, let's say this is a parabola that you are forming with this one, and this will form a line. If the line crosses the parabola at one point or 2 points max, then this is still consistent. If the line goes here, parabola goes there, this is inconsistent system of equations. So basically what I'm trying to say is, concept wise remains the same, just that you are dealing with different types of equations, be it linear equation or be it quadratic equation or polynomial equation. Net, the underlying concept remains the same. If they ever touch, at least at one point, that's the deal. If you're talking about equation with power 3, cubic equation, your this thing might go this way, and then your line might touch at 3 points, right? So the deal is not that it should touch at only one point. The deal is, if you're dealing with a system of equations, if they are touching at only one point, at least one point, then they are consistent, meaning you have a solution. If they are not touching at any point, they are inconsistent, meaning you don't have a solution. That is a situation of undefined, right? That's when you say that this system of equations are undefined, because you are not able to define a solution out of it. Yeah. So and again, you will apply the same elimination or substitution technique. From here you will find the value of x, replace it here. That becomes your substitution technique. What you can do is, you multiply this by 4, add them together, you are eliminating y. That becomes your elimination technique. So be any type of equation, your technique remains the same, the underlying concept remains the same, and the whole objective is, system of equations should help you find out solutions or definite solution. Just one equation alone gives you thousands or millions of solutions, and you are not interested in that. You need absolute or the definite solution coming from the system of equation. So that is where I would take a pause or bring the moment of silence to hear any feedback that you guys have. Any questions?